Good morning, everyone. I would like to welcome all of you to our International Federation of Library Associations global webinar on artificial intelligence and the future of digital preservation today. This is a special webinar organized and sponsored by the IFLA Information Technology section, an IFLA special interest group in artificial intelligence, and IFLA Preservation and Conservation section. I want to begin by thanking all members of our organizing committee through these past months to get us here today. My name is Ray Uzwyshyn, and I am the Research Impact Coordinator for Mississippi State University Libraries in the US, and editor of IFLA's IT's Trends and Issues in Library Technology. I will be your moderator today. We have a very, very special session for you, and I'd like to warmly welcome our speakers, sponsors, panelists, and guests, and go through some of our webinar logistics. Just to outline our rules of order, our main speaker, William Kilbride's keynote, will be half an hour, followed by 15 minutes for each group of our panelists. I've asked our chair of our IT section, Corey Lampert, to give a signal tone at the 3-minute mark, so speakers will know to begin to wrap up their presentation, and another tone at the minute mark to signal speakers to conclude presentations so we can move to the next panelist. I'd like to ask audience members to hold their questions until the end of the panel. We have approximately half an hour for questions after both our keynote and panel. If you would like, please enter your questions in our chat, and one of our committee members, Alenka Kavcic, will note these down for our question period, but feel free to also hold for our question period. This session is currently being recorded and will be available for everyone. And we are also planning a special issue on IFLA's trends and issues in library technology and soliciting proposals for papers from both speakers and our other interested contributors to IFLA, digital preservation, and AI for later in 2024. We have already accepted a paper by Hussein Kampwala of India and encourage panelists to also submit proposals for a special issue. I'd now like to be asking for brief greetings from our main IFLA organizing committee chairs, followed by introductions of our main keynote speaker, William Kilbride, Executive Director of the Digital Preservation Coalition. This will be followed by introductions of our panelists, representing our global IFLA libraries and constituency, and representing countries of Brazil, Hong Kong, and Italy. With that, I'd like to begin with asking for brief greetings from our IFLA section chair, Corey Lampert. Corey, the floor is yours.
Thank you, Ray, and thank all of you for joining us today. My name's Corey Lampert, and I'm the head of digital collections at the University of Nevada, Las Vegas Libraries. And if information technology events are of interest to you, I would encourage you to get in touch with the IFLA groups involved in coordinating this event today. IFLA sections and special interest groups are all volunteer run, and we welcome you to participate. You do not need to be a member to work with us. And to echo Ray, I'd like to thank the entire planning committee for their work, and especially thank a couple key volunteers, Alenka Kavcic, the lead from the IT section on this project, Francois Xavier Boffy, our information coordinator who's providing support for the Zoom meeting, and Ray Uzwyshyn, our moderator. Back to you, Ray.
Thank you, Corey. I'd like to now introduce our next speaker, Ornella Foglieni, Chair of IFLA Preservation and Conservation section, to give brief greetings from the section. Ornella, the floor is now yours.
Thank you for your introduction. I also would like to bring you a very brief personal and warm greeting as Chair of Preservation and Conservation section of IFLA to those attending. I'm very grateful to my IT colleagues, all the colleagues, Cory, Alenka, and the other. They name it's very difficult to explain for me, but I thank all for their assistance and their contribution. And together work together in impeccable commitment and competence to build this initiative. My primary intent was to probe and know as much as possible what can be achieved or done better and more for preservation and care of cultural heritage, not only in documentary field sedimented in the traditional place responsible for conservation in libraries, archives, and museums, but also insights on public and private territory of interest to the community, local community all over in the world. The expectation on the possibility of AI in our daily operational sphere are all to be analyzed and evaluated, as well as the experiences and experiments underway in the world, even in different fields, but which can also be an inspiration in our area of interest. Knowledge, for example, that AI can help in health. For me, it's very important to copy what they are doing for health and suggest us ideas on what we can do and could be done in our culture field. Consciously preserving the testimonies of the present and recent digital past in a systematic and shared way as much as possible in a great undertaking. We must all be committed. This challenge requires strong investment for research and systematic management, not always available, but above all, it requires great awareness and the interdisciplinary skills, as well as joint actions and the various organizational levels of cooperation and collection and services for best management of the digital and its reuse in the future, with attention to its sustainable care, digital, and of course also the physical heritage. But one cannot fail to consider the strong and rapid climate changes and disaster of various kinds in the world which gave no respite, and the repercussion on local communities and their lost cultural heritage and lives in more cases. Perhaps something more should be done to prevent them and save heritage in its various forms. We must become capable of convincing those who decide with certain data and facts. I stop here and I hope that you can enjoy the webinar with interest. I would also be happy to receive your comments and suggestions via email. Thank you for your attention. Thank you.
Thank you, Ornella, for those comments from the preservation and conservation section. Finally, I'd like to cede the floor to Dr. Andrew Cox to give brief greetings from IFLA's IT section, Special Interest Groups in AI. Andrew, you have the floor.
Just hold a second. I think he's not with the right.
I believe Andrew's put his message in the chat. He invites us all to join the IFLA AI SIG, where they share news about AI and libraries, and he's really looking forward to the event. Thanks, Andrew.
Thank you, Cory and Andrew.
Yes, he can speak now.
With that, I'd like to introduce our keynote speaker today, William McBride. William Kilbride. William is Executive Director of the Digital Preservation Coalition, a dynamic sector-making charity that provides community, advocacy, workforce development, and good practice in governance in digital preservation. William started his career as an archaeologist in the 1990s, with an unusual mix of qualifications in computing and archaeology, and has been working in a variety of digital preservation roles for 25 years, including as Assistant Director of the Archaeology Data Service and Research Manager at Glasgow Museums. In 2020, he was jointly named Information Manager of the Year by the Chartered Institute of Library and Information Professionals, and in 2022 appointed an honorary professor in the College of Arts at the University of Glasgow. We are very much looking forward to your keynote, William. And with that, the floor is yours.
Well, thank you, Ray. Thank you all very much. I'm just going to take a split second here, make sure you can all see the screen that you're supposed to be seeing. Mostly it's eye candy. It's going to be better looking than I am for the next 30 minutes or so. Can you all see that screen okay? Does that all work for you all? Someone let me know. Yeah, thank you, Ray.
Yes.
And with that, I'm going to get myself, just set a clock running here as well, Corey. You'll be pleased to know, get myself underway. So thank you, Ray. Thank you, colleagues at IFLA, for the warm welcome and for giving me the opportunity to speak today. Such has been the pace of development in digital preservation and in artificial intelligence. I think we're all on a learning curve, and I fully expect to be gaining more than I contribute. And I'm very excited about the case studies and the conversations that will follow my own presentation. I feel it's important to say out loud that I am really here, whether or not you're really there or not. I have written a presentation the old-fashioned way, reading a lot and talking with colleagues as well as with some experimentation of my own. I promise none of the paper is machine generated, although you may wish in due course that it had been. And of course, in this AI domain, if the paper doesn't meet your approval, then you're at liberty to generate a version of your own now with the use of appropriate chat tools. I've taken the unusual step of scripting the presentation because I know I speak too quickly and sometimes digress. So the script will keep me to time and to subject. And I'm going to share the text afterwards. So by all means, make notes, but the full text will also be available shortly. And I have 6 themes for you in the next 30 minutes or so. I want to start by outlining the digital preservation challenge as I perceive it. That might mean that we cover some familiar ground, but I don't apologize for that. A key concern for really any new technology, especially one with a hype curve as sheer as artificial intelligence, is to ensure that we focus on our objectives. The history of technology is littered with solutions which are looking for problems. Let's get that the right way around. I then want to explore 4 ways in which digital preservation and artificial intelligence intersect with each other and consider how we might make progress. We can use artificial intelligence tools to do digital preservation. I'm thinking here about the tools which can support ongoing digital preservation challenges, such as appraisal or selection, or metadata extraction or forensics. And as a spoiler, I think we're going to have some great case studies and discussions about that as the session continues. AI also puts a bit of pressure on digital preservation and arguably makes some of our roles and functions more important. So I want to lead a brief discussion about misinformation and disinformation and the aspects of digital preservation which maintain and promote authentic knowledge. There are some useful things here to report, but there are also profound challenges of capacity and capability. These need urgent attention. Then I want to consider the contribution that digital preservation tools and services can make to the development of AI, whether as training data, language models, or algorithms. This may seem niche, but there's actually a good story to tell. There are reasons to suppose that some of the large language models have simply grown too big, and there's an opportunity for libraries and archives and others to step in here. Finally, I want to explore the possibility of preserving artificial intelligence itself at a systemic level. I grant you this might be a flight of fancy, considering the size and complexity and incomprehensibility of the task I set before us. But I also firmly believe that reproducibility is essential for accountability and for trust. And so I am really challenging the confidence that is placed in some of these tools with an implicit call to action. At the end, I want to sketch a simple agenda to ensure that digital preservation benefits from and contributes to the development of better and more accountable artificial intelligence. And I'm going to remind you that digital preservation is a socio-technical challenge and all the technology in the world can't solve it alone. So the ways in which AI is embedded within law, within policy, within business processes, all of this will matter, and we should not allow ourselves to be overwhelmed by tech. The Digital Preservation Coalition will be a friend, an ally, and partner to those conversations. I have our 30 minutes allocated, but please do use all the usual functions to ask questions or to make notes. And I'm looking forward also to the discussion that will follow, not simply in this formal session, but in the conversations and shared thinking afterwards. And I start, therefore, with an open offer of friendship and support to achieving your own goals. So to provoke you at the very outset, what would you like to know about artificial intelligence and digital preservation? What would you like to do? Let's take a moment, write that down and bring it back to the table for conversation later. So let's start at the beginning. Digital preservation, what is the problem? Digital preservation is the series of managed activities necessary to ensure continued access to digital materials for as long as necessary. There are bits in bold here which are worth emphasising, and that'll frame some of what follows. It's a series of things, not an event. It fits within a policy framework. It's a bit more than backup, and it's for as long as necessary, not forever, and certainly not everything. It's not just about data or informational content. The phrase materials is pleasantly vague, and it's not just about digitization. And because digital life cycles are short, lots of agencies, which are not libraries or memory institutions in the traditional sense, find themselves with the digital preservation problem. The digital preservation problem arises in all sorts of ways, really just about any single way in which you can lose access to programs or data. And some of these challenges are themselves dynamic, so there's not a once and for all solution. There's a continuing commitment, which in turn means that policy and resources are as important as technology. Over the years, tools and standards have emerged, and it's fair to say that many of the issues are tractable, but the solutions are too often not scalable. Context makes a significant difference. So while I can point to lots of good practice and good experience, oftentimes the answer to any digital preservation question begins with a slightly disconcerting phrase, it depends. Let me give you two examples. Metadata, or perhaps more accurately, packaging information is never not an issue in digital preservation. Achieving the independent utility of a digital object means providing a lot of context, and there's a risk of almost infinite regression here. In a conceptual sense, you need to document the whole of human knowledge to make a single digit meaningful. This is the OAIS information model for those of you familiar with it. That idea of having to package the whole of human knowledge to make a single digit meaningful is absurd, partly because human knowledge is pretty well documented elsewhere, and also because you should be able to anticipate a degree of background knowledge from a community of users who will know more or less about the topic. So representation information is itself interpreted by representation information up to the point where you reach a level of knowledge within the designated community. So the question arises, how much metadata do you need for effective preservation? And the answer I give back to you is, it depends. I'm labouring this point for two reasons. Firstly, there's a school of thought in digital preservation which would tell you that archival information packages are the distinguishing characteristic of digital preservation. And experience shows that the process of creating these archival information packages can be arduous. So approaches like minimum effort ingest have emerged as a way to deal with this. Get the data first, sort out the metadata afterwards. This is a real problem. It's not one we've made up. And guess what? Coming up this afternoon, AI tools that help us deal with metadata creation. A second related issue, understanding dependencies. I want you to imagine a simple Word document. Preserve it and ask yourself whether or not you need to preserve the font too. Well, sometimes yes, and sometimes no, and sometimes it will be embedded within the file anyway. But not always, and in those circumstances you may discover a dependency on a remote service which may or may not be available to you. Scale that up away from word processing up to the level of the cloud and all the interactions that happen there, And before you know it, you have services built on microservices, all of which need to be mapped and risk assessed as part of a preservation process. I mention this for two reasons. Firstly, mapping dependencies at the scale of the cloud, risk assessing them and firing up services that can replicate broken dependencies sounds like exactly the kind of tool suite that we need, especially if we want to recreate not only data, but the entire execution environment of a given application. And it's the kind of fly-in-the-wall problem solving that AI would do very well with. But remember, this is not just all technology. Dependence is not just technical. It's also an economic reality. Digital preservation teaches us that, especially on cloud platforms, data loss can be the outcome of business processes and economic realities which are way beyond our control. Creating dependencies on enterprise-level AI systems at a time of market turbulence should be setting off alarm bells. Remember here the central paradox of digital preservation systems and tools. They are susceptible to the same kinds of obsolescence as the materials they're designed to preserve. Okay, so you're here for the artificial intelligence, and that's what I want to turn to now. In truth, I've said a lot of what I need to say already here. There are some wonderful emerging tools that are making simple but practical contributions to the way we do digital preservation and making it tractable at scale. In a moment, you will hear case studies of metadata extraction and classification. You'll hear studies from music, from image processing and audio transcription, and you'll hear about digital restoration. These are all tools that will help, and they sit within an emerging AI toolkit for digital preservation. And it's worth sharing a few others, which will all be linked in due course from the text. There's some very practical work from the World Bank Group, for example. They have a long tradition of automatically recording their video conferences, generating massive quantities of data. But the reality is that not every meeting goes ahead, and many meetings start late, and once in a while, the meetings finish early. So the collection of recordings includes significant amounts of dead air, which clutters up the servers and makes it hard to find the right material. Jean Kramer-Smith has demonstrated simple recommender services based on machine learning that speed up the clipping and disposal process to ensure the archive is not inundated with dead air. AI has allowed for advances in handwritten text recognition. There are colleagues on the call better placed to describe this. For example, the use of AI within the Transcribus suite, which has been trained on digitized handwritten texts. Joe Nockels has described using AI at the National Library of Scotland to help with the transcription of the childhood diaries of Marjorie Fleming. This is important. It's not just a technical accomplishment because it's hard to hear the voices of female Scottish children from the early 19th century. So it gives access to an authentic and overlooked voice. There are so many authentic but overlooked voices sitting in the digitization projects which we all have engaged with that are just waiting to be heard. I'm also a fan of the work at the White House Historical Association, which owns a massive but largely uncatalogued photographic collection produced from years and years of official White House photography. By using Amazon's recognition tool, Stephanie Tuzinski has been able to identify the subjects of many thousands of these photos, opening up access to collections of around 300,000 images of daily life at the White House. Essentially, everyone who visited the White House in the second half of the 20th century is there. Also supporting access, but at a different kind of scale, Leontine Talbot, previously at the National Archives in London, has sketched out practical guidance to computational access for digital archives. This seems to be important because it moves the dial a bit at a service level over and above individual case studies. We need to provide access, and Leontine's work helps set and manage expectations and needs of readers who don't simply want to access individual documents in the reading room. Access will be like this in the future, when users bring their APIs to our AIPs. And these are just a few examples that I'm looking forward to having a deep dive into in a moment from our other speakers. There's also a lot more we could be doing. For example, there are well-developed tools and processes to assess fixity in digital preservation workflows. Checksums will quickly tell you if a file has changed, but they make no comment on how egregious that change is or what might have caused it. And in a strange way, that's your worst nightmare as a manager. The question arises whether we can use AI tools to do better, to identify and assess the scale of the change, and to make an informed assessment on how that change came about. So these emerging tools are welcome, and there's a lot more we can be doing, provided we focus clearly on real digital preservation objectives and the obstacles that prevent us from doing a better job. It's worth putting this in context, especially as we talk about the scale of the problem, because time and money turn out to be one of the biggest challenges facing our shared cultural heritage. There are lots of examples, but here's a library one that you'll find familiar perhaps from your own context. The UK Web Archive at the British Library, which is gathered under statute by an agency established for the purpose, is a case in point. In 2017, the DPC studied the impact of changed regulations on the Web Archive, and we noted that it had grown from 365,000 discrete collections to almost 14 million discrete collections over a 5-year period, a 38-fold increase, which has not been met with an equivalent increase in funding. My point is, we need all the tools we can get simply to stand still. It seems to me entirely obvious that the digital preservation's interactions with AI will also be about the preservation of content which AI has helped to generate. There's a wall of content coming our way, and how we handle it could have profound implications. There are numerous examples, comic and tragic, of AI being used to simulate text and images that seem convincing, and which are then lifted out of context, and which, if we're not careful, will find their way into official and legal processes to form a completely erroneous historical record. You should look into the case of what happened when Roberto Matta sued Avianca Airlines in March 2023. Matta's lawyers filed a suit which, unbeknown to lead counsel, had been compiled with a little help. It quoted key legal opinions and judgments demonstrating that Matta's case was an open and shut one, and that the airline should settle before the case reached court. But it was a surprising reversal when the judge and the defense team asked Matta for copies of these previous judgments, which they couldn't find because they didn't exist. Matta's lawyers was basing his case on bogus decisions with bogus quotes and bogus citations. ChatGPT had simply guessed the cases into existence. The judge fined Matta's legal team, ruling that they had abandoned their responsibilities to the court. His judgment described the gatekeeping role of attorneys to ensure the accuracy of their filings. It's not an isolated case, though, and later that year, senior judges had to issue renewed guidance to attorneys about the use of generative AI in proceedings. The Matta case is a textbook example, precisely because the judge spotted the error and stepped in before it went any further. But that's not always going to happen. Bogus records will be cited, and sooner or later, probably already, the courts or other regulators will accept them onto the official record. Now, this is a case of misinformation, perhaps a lazy or overworked assistant reaching for a cheap solution they don't fully understand the implications of. They made no attempt to cover their steps, and they made an immediate and fulsome apology. What will happen when someone sets out deliberately to create and insert false records into the archive and library systems? It may be years before such fraud is detected. So my point is that we have to be working very hard to protect the record. The question arises, therefore, how do you detect AI-generated nonsense, whether it's deliberate fakes or lazy simulacra? I have 3 reasons to be pessimistic about the prospects of protecting the record from these kinds of disinformation and misinformation. On one hand, there's just the brutal reality that digital preservation roles are not funded and not taken seriously. We have an extraordinary investment in cybersecurity, and rightly so, but laughably poor investment in information security. We already face a crisis of public confidence in government and the transparency of process. So my strong sense is the weakness of our ingest and transfer processes need to be declared a public emergency. Even if our appraisal and selection records were properly funded, we would still struggle because of the volume of fake news and the ease with which it has been created. The deluge is here already. So the question arises as to whether or not there's an AI solution to an AI-generated problem. For sure, it's possible to code fakes in such a way as to make detection easy, and that might be the direction of travel for regulation. But that sounds like an invitation to an arms race, or at least a way to lower our guard, because as sure as there are safety features built in, so there will be workarounds. And there are AI tools like GPT-0 that already claim to spot AI-generated text. These next generation plagiarism detection tools misidentify about 1 in 20 examples of human-generated text. That proportion needs to come down if the usefulness is to improve. Even more alarmingly, they have a tendency to reverse engineer hidden biases within large language models. So non-native speakers are reportedly 10 or 12 times more likely to be suspected of plagiarism. Can digital preservation support the development of AI? This may be less obvious, but I think yes. I think digital preservation has a role in the development of AI, and it's not unconnected to this need to verify authentic content. I'm particularly thinking about large language models here. Large language models underpin text simulators like ChatGPT, and they're voracious eaters of content. It's hard not to be impressed, if not a little scared, at the pace of their growth. They provide the statistical basis for transformer tools that then essentially make informed guesses about what word should come next in a sequence. The larger the sample of text, the better or more convincing the performance will be at guessing which string of words to deliver. That's the basic model of generative pre-trained transformers, GPT. The company behind these systems are circumspect about how much data they have crunched and where it comes from, but you can reverse engineer some estimates to give you an idea of their consumption patterns. In late 2022, ChatGPT 3.5 was reported to work through around 175 billion parameters in order that it could simulate text. ChatGPT 4, released in March 2023, is reported to have around 1 trillion data parameters for the same task. That's a 5-fold increase in less than a year, and it's an incredible rate and significantly faster than the growth of the internet. That points to a coming issue. The internet is very, very big, but it's not infinite. There's an upper limit to the amount of human-generated text that the internet can supply. Some industry analysts have suggested that large language models may begin to run out of data, perhaps as soon as 2026. And it's hard to see how they can continue to improve beyond the point where they've consumed the whole of machine-readable human text. I want to plant that idea with you now because access to our digital collections may help with that. It's not exactly as if the big tech companies have been paying much attention to the restrictions that libraries place on use, but it's possible they'll start to pay more attention. Here's why. Large language models are indiscriminate consumers of text, and GPTs are profligate producers too, and this might be their downfall. Sooner or later, large language models will start to consume their own simulated outcomes. In statistical terms, they will start to revert to the mean instead of becoming better at producing text. They'll become better at producing the average. At the same time, they will inevitably consume misinformation and disinformation. So over time, the outputs become both less creative and less reliable, a sort of system collapse, the sort of thing that happens when you start to breathe your own exhaust fumes. As the saying almost goes, garbage out, garbage in. So there will come a point where large language models cannot improve except with access to more high quality human generated text. They will need to know this information content is valid and not stuff that they have consumed before. We keep being told that digital content in the GLAM sector is locked away and hard to access. So it's just possible that the solution for the large language model conundrum is better access to and better prioritization of digital libraries and digital repositories. I want to turn my attention briefly to what might be described as the biggest challenge of all, Can we preserve artificial intelligence at a system level? The argument as to why we should want to make AI reproducible seems unimpeachable. There's an old maxim reported from IBM that computers cannot be held accountable, therefore should not be allowed to make decisions. We seem to have forgotten this rule. Some of the earliest developments of AI were in expert systems which were designed for diagnostic decision support. But lately, there are all sorts of uses that seem to go beyond decision support and move directly to action. Facial recognition is a case in point. It's notoriously unreliable, failing to recognize faces in up to 80% of the time, but still deployed routinely on the streets by police forces in the UK. AI supports immigration decisions, insurance premiums, university admissions, healthcare plans, and credit ratings. It's analyzing long-range population demographics, it's condition monitoring vital infrastructure, and it's targeting political and social messaging to the millions. You would hope that such systems could be held accountable and challenged to reproduce their outcomes. But AI systems typically embed their own learning through reinforcement. This is one of their most important characteristics. They are dynamic. They respond to their own outputs such that every iteration is subtly different. There's no steady state, and with complex dependencies across a staggering range of tools and services, the changes are hard to trace. So the prospects for reproducibility and thus accountability are inherently weak. It's not all bad news, though. There may be some hope in the context of open source. One of the most telling developments in the last year has been the sudden glut of open source AI tools based on open source language models. This has partly happened by accident, can you believe? It's partly because Facebook inadvertently released Llama and the emergence of some surprising low-cost but highly effective competitors like Koala or Vicuna. There's a sense in which systems like Bard or ChatGPT, which have been built with billions of dollars of investment, have been built without moats or defenses, as Luke Cernow of Google admitted. In recent months, the open source community seems to have wrestled control of the one or two major corporations who have invested so much over the years, and the open source community seems to be running off with capabilities that have cost billions to develop. Why does this matter for reproducibility and digital preservation? Well, it's harder to hide open source architectures within black boxes. It's harder to conceal open source workflows with non-disclosure agreements. The secret sauce turns out to be just sauce, and it makes it one step closer to reproducibility. We've covered a huge amount of ground in this presentation, and there's so much more we haven't covered. No mention of copyright, no mention of environment, no mention of the human cost of automation, no mention of problematic military and coercive use cases which have sustained and underpinned so much research. I've not raised regulation or lobbying or the apparent ease with which high officials act in the interests of those whom they should be regulating rather than the publics they're committed to protect. I've not mentioned interference in market or elections or extractive exploitation of data by vulnerable or marginalized groups. I've not mentioned obscene profits or the feudal relationships that have emerged around new kinds of rent-seeking behavior. Ethics have hardly surfaced at all. It's not that they don't matter, it's just that I've only got so much time. I can see Corey has lit up. There's a lot to be getting on with. So I want to end with a simple 4-point research development roadmap for AI. And I want to suggest 4 things we should be doing. We should investigate, benchmark, and share best practice for AI-based tools that support and enhance digital preservation workflows, such as but not limited to appraisal, metadata extraction, forensics, and access. We should establish frameworks for the assessment of content generated by artificial intelligence, alerting governments and other authorities to the coming threat to authenticity and accountability that rise. We should declare a public emergency. We should be prepared to engage with the AI industry directly, making sure that ethics and the competencies of librarianship are represented at the highest level, making the case for existing authentic but inaccessible content as a contribution to AI. And we should create urgency and momentum towards the preservation of AI at a systemic level to ensure that it's reproducible as a core component of accountability. This agenda is not limited to the 30-minute time frame of the presentation. So it absolutely must take place in the context of all the other ethical, legal, social and economic matters which I have overlooked. To repeat what many of you have heard me say before, in which the street signs here in Glasgow almost say, people make digital preservation And if we concentrate too much energy on technology, we'll never fully succeed. Digital preservation is not for the sake of the bits and the bytes. The files will not thank us. So the research agenda has to be framed not simply around technology, but what will be most effective at empowering people and ensuring opportunities are handed on through generations, independent of technology. That should keep us plenty busy. And if you hadn't noticed, the DPC, the Digital Preservation Coalition, is a ready-made global partner in that conversation. Thank you again for your time today. I hope you found something useful in this presentation, and I'm grateful once again to IFLA for the warm welcome and generous invitation to speak. Thank you very much.
Thank you, William. That was a fascinating, insightful, and comprehensive overview and keynote, and sets us up very well, both for further reflection, but also for our next panelists. With that, I'd like to begin introductions to our next panelist. Our first panelist of the group is Herbert Menezes Filho from Brazil. He holds degrees in archival science, the Federal University of Bahia, technology, and systems and analysis, and a master's degree in information science from the Visconti Cairo Foundation. Mr. Menezes Filho works in areas of information and archival science, with an emphasis on academic and personal archives, digital certification, electronic document management, and open source software. Herbert will be speaking on artificial intelligence, situational analysis, and digital preservation at the Federal University of Bahia. Mr. Menezes Filho, welcome, and the floor is yours.
Audio okay?
Yes, good job.
Hello, my name is Herbert Menezes Filho, Information Science PhD student. It's a pleasure to be participating in the global webinar on artificial intelligence and the future of digital preservation. I would like to congratulate you the initiative of the International Federation of Library Associates and Institutions. I have to say that my English is not very good because I have prioritized reading and reading more. I hope I can express myself well so that you can understand. The topic of my presentation today refers to a part of my doctoral thesis. The title of my presentation is Artificial Intelligence, Situational Analysis and Digital Preservation of Archives at UFBA. The script of presentation is as follows. 1. Purpose of the research. 2. About UFBA. 3. Process for digital preservation. 4. EA design of use and perspectives. This paper proposes a situational analysis of the collection of the Federal University of Bahia, UFBA. The main objective is to explore how the application of artificial intelligence, especially in automated generation of metadata and its application in the categorization and classification of content. Before we talk about digital preservation, we should talk about memory. Memory has been a topic of interest for several areas of knowledge, such as philosophy, information science, archival science, story, and librarianship, by presentation challenges, especially and with regard to the new problems arising from the production, dissemination, and use of information technology. However, we must understand that memory is characterized as a complex phenomenon, which can be influenced by political factors, in addition to the actions of forgetfulness and distortion suffered over time. This memory and forgets are basic elements in such memory systems, because digital preservation considers the retention and perpetuation of memory and access to information, otherwise constantly forgetting. The collections of cultural and education institutions face significant challenges related to the organization, preservation, and accessibility of the materials, pieces, and the digital which increase the volume of digital content and the diversity of digital media formats. It becomes essential to adopt innovative approach to address the issues. Since the research university is UFBA, a public institution of higher education located in the city of Salvador, Bahia, Brazil. The sample selected for the research is defined by the UFBA units that have collections considered to be great importance and of a permanent nature. Place of memory by students, collection of musical historic documentation, density memory. The mission of memory units consist of place of memory to administer, organize, preserve, and disseminate information resources in accordance with scientific and technological innovations in order to promote access to the production of knowledge, which are viewed to educational, scientific, social, cultural, and technology activities of the institution and the development of society. Place of memory by students preserve and give access to the college to the community research. In addition, support research activities reinforce the mission of university libraries that seek to promote quality education in different areas of knowledge. Collection of music historic documentation. Preservation of music and music-related documentation and process of the information content trained in order to ensure access for research purposes and when legally possible, disseminate over the internet. Dense memory to safeguard the memory of the tragedy of the UFBA School of Dance. Identify and affirm the static academic production of the institution and impacts of the Brazilian dance scene. We can say that these preservation boards have a great responsibility towards the institution and a member of society. Questionnaire was administered today for 4 memory units divided as follows. 5 questions on the presentation of memory units. 4 questions on institutional objects. 5 questions about the staff. 16 questions of the collection and standards. 25 questions on digital preservation and artificial intelligence. Due time, we will not be able to present the results, but will be available in the full work. In this way, we were able to better understand the units, understand your situation, especially the challenges and needs of managers and employers. There is urgency in defining the most appropriate policy, obligation, and methodologies for the management of digital resources. We highlight the psychology, computational archive science, which characterizes as transdisciplinary field that integrates theories, methods, and computational and archive resources. This integration aims to support the creation and the preservation of reliable and authentic records and files, as well as other the process analysis, storage, and access of records and files at scale. With growth of ICTs and the production of various digital documents in different formats, the technologies that quickly become obsolete. The research in question focuses mainly on 2 archival technical resources: ESO 14721, Informatic System for Open Archive, OIS, Reference Model, and ESO 16363, Audit and Certification of Trust Digital Repositories. Below, I present 2 basic models for all research. The OIS model is reference for preservation digital systems is composed of 2 models, the functional model and the information model. The functional model describes the functions that OIS repository should perform, while the information model proposes the concept of information package. UFBA uses various software, namely Managed Software SIG-A, CPAC, SIG-RH, and Information Producers, say Protocol Software, Alfresco Electronic Document Management, Pergamo Libraries, the Space Storage of Theses and Dissertations, Archivemática Preservation, Environment, Atom, and Dissemination Tainacan. but hold honest and have the information preserved in a long term. Preservation model IPACHA. The IPACHA model began as part of the integration project of the Electronic Justice Journal, a partnership between the Court of Justice of Distrito Federal Brazil and the Brazil Institute of Information in Science and Technology, IBICT, that provided for the transfer of knowledge and technology to enable the implementation of a retábulo digital archival repository, RDCARC, in the local judiciary. This idea was to create an interoperable technology base layer to ensure security and access to the Court of Justice of Distrito Federal digital documents, minimizando vulnerabilities and the possibilities of possible cyber attacks, which could put integrity of this data at risk. The main purpose of the base was to automate the process of preserving digital objects. In the words, facilitate the transport of submission SIP, archive IMP, and dissemination package SIP, DIP. Templates of promote standard on the interoperability, sustainability, security, and authenticity, institutional responsibilities. Automated metadata generation is an area of research with which powered algorithms are employed to extract relevant information from informational actors. In the context of UFBA collections, the automated generation of metadata can help identify and catalog important information about the entities in the collection, such as title, author, date of creator, producer, historic context, and thematic connections. Such as Tynacan software used para dissemination of files the web and várias formas of metadata managed taxonomy and entidade relationships. It's important to note that Tynacan is a WordPress plugin developed in Brazil. The purpose under developed is the use of artificial intelligence and machine learning to recognize para the partner established in the questionnaires and strengthen these search and retrieval process through metadata, such as the use of Adobe Bridge PDF written in .csv or XML. The proposal of the model discussed in thesis is we establish 7 stages that will guide the institution in the process of digital preservation and use of artificial intelligence for the management of institutional archives. Stage 1 consists of performing assets of the institutional situation, we begin performance in the memory and mentioned, so that the institution can have an overview of this context. Stage 2 consists of performing digital curation, which will survive all this software in the institution. In addition, to verify its possible integration with artificial intelligence mechanism, to be able to better understand your technological park. Stage 3 consists of elaboration digital preservation policy, which are the guidance and the institutional definition provided by the University Council. Stage 4 consists of design digital preservation programs that will put into practice the definitions of digital preservation policy. Stage 5 consists of the elaboration action plans, which the most practical part of the project, in which actors and the responsibilities for implementation will be defined. Stage 6 consists of checking and monitoring the implementation and the results of the policy. And finally, stage 7 consisting of addressing the conformidades funds. We are conduct of reflex white rigor indication where the consequence analysis is still preliminary. In order to research more substantial conclusions, further analysis will be required. This initial exercise also requires constructive criticism for each developed. We hope that such critics will be elaborated and welcomed by fellow scholars and interdisciplinary themes involved. To contribute to a continuous improvement of your work. Much more than using technology, we must think about sociocultural context of organization and to need to highlight institutional policy. Obrigado a todos e a todas. Thank you all.
Thank you, Mr. Menezes Filho, for a very interesting and illuminating talk, especially on the project level and complexity of these projects with AI going on in Brazil. Our next speakers are also from Brazil, Dr. Pablo Gobira and Ms. Emanuele Silva, also from Brazil. Dr. Pablo Gobira, who will not be with us today, is a professor at the Guignard School, University of the State of Minas Gerais, member of the permanent staff of the graduate program in Arts and Built Environments and Sustainable Heritage graduate program. Dr. Gobira could not be here today, and Emanuele Silva, his co-lead in this project, will be speaking for both of them. From UEMG. Dr. Gobira and Ms. Silva will be speaking, or Ms. Silva alone will be speaking on using AI as part of the recreation strategy in digital preservation. The floor is now yours, Ms. Silva.
Thank you so much. Hello, my name is Emanuele Silva. I speak here also on behalf of my mentor, Professor Dr. Pablo Gobira, with whom I had the opportunity to be part of the work presented, titled Using AI as Part of the Recreation Strategy in Digital Preservation. It stems from the discussions at LabFront, a research development and innovation group based in the Guignard School of the State University of Minas Gerais in Brazil, of which I'm a member since 2018, under the coordination of Professor Pablo. These reflections are the result of a research project supported by the National Council for Scientific and Technological Development, CNPq, and the Minas Gerais State Research Support Foundation, PAPAMIG, and PRO-PPG Weng, to which we are grateful. LabFront is a group that aims to problematize the frontiers between the fields of art, science, and technology, having a special relation with the use of state-of-the-art technology for digital preservation purposes. The topic, as we all know, is especially in vogue now, but we can honestly track discussion on the matter from even before the turn of the 20th to the 24th century. That is because with the widespread use of, up to that point, military and industrial technology, we have seen the exponential growth of digital media. Therefore, in order to be able to preserve the information created with diverse and sometimes disruptive technologies, we saw more clearly the need for a case-by-case methodological approach through a digital preservation lens, which, as we all know, causes difficulties for discussions inside the field of preservation, as it makes it impractical the development of a preset system or pattern of work that would work in all cases, because, well, we wouldn't. The specificities in media format, language, storage, amongst others, on its own would already create a headache when dealing with matters of preservation. But when talking about certain specific types of digital creation, like digital art, we also need to take into account the fact that the digital artwork isn't just digital. It is a mix of industrial and or exclusively created hardwares and softwares, as we see in Gobira 2016. Such characteristics makes for hybrids, new and or otherwise inaccessible formats, both informational and physical, that also need to be addressed as a preemptive preservational discussion. Therefore, although it is difficult to appoint a set workflow that can be used for all such production, exactly because of the specificity enabled by the use of ample diverse technology in their creation, institutions centered around preservation, such as museums, libraries, or other cultural spaces, saw the need for creation of protocols to help with the intention of preserving such work. We can understand digital preservation after Gabira and Correa as the preservationist action that deals with the investigation and selection of what is being preserved, digitalization in case the work isn't originally in a digital media, and conservation through the gathering of information over the work's composition while in use or exhibition. Therefore, in order to come up with protocols, some key concepts need to be taken into account, such as compatibility and format, which deals with the information's language, reading and conversion, something intrinsic to compatibility, and with determined systems and flexibility. Standardization and format conversion of digital information allows for an easier way in regards to accessibility as a means to assure that information produced nowadays are accessible in posterity, accordingly to Cunha and Lima in 2007, and are therefore aimed to by institutions worldwide so as to be interchangeable, practical, and useful. With such demands in mind, the researchers on the field of digital preservation have developed techniques and strategies for its use, starting then to develop systems that aim to guarantee the conservation of such high influx of digital data. One of the first efforts that we can quote here was the creation of the OAS, Open Archival Information System, in the beginning of the 1990s. But beyond that, the preservational strategies can be divided into two categories: structural, which deals with the contextualization needed to allow for the digital preservation, and operational, that deals directly with the techniques, some of which and most commonly used around the globe by institutions are emulation, migration, or conservation, encapsulation, and the focus of the work that we are here presenting, recreation. In the technique of recreation, the artist can create a dimension or the entirety of their work that may have been discarded, such as one does with obsolete hardware and other software media, as we see in Gabira 2016. With such possibility, even with the action of discarding that can happen throughout the preservationist process, the recreation comes as a possibility to redo what was once exhibited, also accordingly to Gabira in 2016. Amongst the ways in which we can use different tools as assistants and part of such preservationist technique, but here with the focus specifically in recreation, there are the possibilities of use of metadata, information that are added to the original data of an online archive, specifying it in different categories in a way that can track its precedence, regardless of its history. Such metadata can be used in addition to other software tools to recreate the media as it was first intended, based on the specific parameters and presets. Another possibility, more recent, to guarantee authenticity and provenance of digital archives that also enables, through categorized information and specific data, the entire or partial recreation of digital media is through the use of blockchain. Besides all that, one very powerful tool that is now being used due to the facilitation in access and the lowering of costs due to its popularity growth is the use of artificial intelligence, AI, as a tool for digital preservation. Specifically, when dealing with recreation, we can see its potential, seeing that AI techniques can be used for the digital preservation, not only of digital medias, but also the considered traditional ones. With one of the most famous cases that we can quote being the use of AI to recreate and preserve Rembrandt's Night Watch, a painting by the famous Dutch painter finished in 1682, that a strip of its left side cut off around 70 years after it was finished to facilitate transporting, causing a change in the viewer's perspective of the main characters, placing them in the center of the canvas as opposed to the position more on the right, where the painter had originally intended them to be. Now displayed in the Rijkens Museum in Amsterdam, it underwent what was called by the museum director Taco Dibitz a restoration process, so named Operation Nightwatch. One of the many preservationist ways to deal with artworks making use of AI to recreate the painting's originality, seeing the strip was lost to time. We also have the case of the National Library of Norway and the digitalization of national heritage preservation, where after dealing for more than a decade with the costly and timely process of critical digitalization, also named slow digitalization, they plan to now, in the second phase, after getting the original artists or authors agreement, and once having the work updated to the digital assets management system, to make use of AI, specifically with machine learning, as preservational tools through recreating part of the digital work, through enhancing its metadata accordingly to the needs, I think to the original creator being low in cost and time. One of the hardest challenges the project has been facing since its start in 2006. Just a second, I'm parched. We also have the case, I'm spoken. When it comes to archives with a large amount of information or data and a high influx of wanted actors, the use of artificial intelligence as a guide in archiving is an interesting and unique innovation to implement. AI Archivist is a digital library concept that provides information using a system that is directly integrated with the information in the archives. The AI Archivist becomes a guide and translator of the wishes of library users through a large monitor screen with several features that are adapted to specialist subjects in the classification of library material information. The way we can analyze that is, once again, the use of AI for speed and cost reasons, making what was done step by step by human agents, recreating a media in a specific format, language, or accessibility, reaching the biggest force behind the preservationist studies, which is the accessibility of information throughout time. One final example we can bring here is the use of AI as a tool for what is being called long-term digital preservation, LTDP, or simply digital preservation, where, to put it simply, enabling a specific data with AI systems, depending on the goal, we could possibly understand a digital object as a living thing, understanding the network as an interacting environment shared with other objects. It moves in from node to node, duplicating and evolving, cooperating with other files, with the final objective of guaranteeing the persistence of the information contained within it along its descendants, accordingly to L5D and Rosa 2021, enabling the digital object to recreate and therefore self-preserve itself within the system. Although there are some other examples we can discuss here, I'm afraid we are reaching our time limit, but I hope we are able to showcase, even if just a little, the possibilities that are being opened thanks to the widespread and the developing use of AI as a tool, in not just but having it as its central point, the recreationist technique in the digital preservation field. I invite all of you to follow LabFront in our website, where we are always updating with new papers, chapters, and books within our research, not only in regards to preservation, but also other matters dealing with the mix of artistic, scientific, and technological fields. And also to follow us in our social networks, where we continually post new projects, exhibitions, congresses, and a lot of it that our team is currently participating in. Thank you very much to the IFLA for having us.
Thank you, Emma, for that very interesting talk regarding intersections of art, preservation, technology, and AI. Again, fascinating topics that you presented for us this morning or afternoon for everyone. Much to reflect on with the projects you introduced going forward. Our next speakers, Miss Holly Chan and Mr. Jack Lau, are from Hong Kong. Holly serves as Assistant Manager, Digital Humanities, Hong Kong University of Science and Technology. She works to develop digital humanities and digital scholarship projects for the university and supports faculty, students, and the use of digital tools and methods for research, teaching, and project development. Jack Lau is a computer engineering student from Hong Kong University of Science and Technology and has made contributions to the library's digital initiative projects. In their presentation, Beyond Pixels, AI-driven image processing for enhanced contextualization of Hong Kong University Science and Technology's digital images, Holly and Jack will showcase AI's use in enriching data and providing context for each photo, sharing practical experiences, outcomes, and lessons learned from this testament project. Mr. Chan, Ms. Chan, and Mr. Lau, the floor is now yours.
Thank you, Raymond, for the introduction. Hello, everyone. I'm Holly from the HKUST Library. In this presentation, together with Jack, a year 4 computer engineering student in our university who contribute a lot in this project, we will share how we experiment with different computer vision models to enrich the data in one of our library collection, HKUST Digital Image. Before diving into our experiment, I will first briefly introduce the background, then Jack will share our attempt on using various models to perform the object detection, image tagging, and face recognition tasks. Finally, I will conclude what possible work we could do further based on this attempt. So, why we click start this project is because in addition to AI literacy, we, the HKUST Library, would like to further extend our scope to include AI utilization with the university community. So we have implementation started in February this year that offer part-time job opportunity for undergraduate students to explore the state-of-art technology, apply their skill and expertise through hands-on experience in practical scenarios through our digital project. And the project mentioned in this presentation is one of the projects in our initial round of this initiative. In this project, we provide the photos and existing data from the HKUST digital image as sample data to our 2 student developers, Jack and Eric, with the purpose of enhancing the associated metadata, making them more informative and provide richer context for each photo. So, what data is exists in our HKUST digital image? This site serves as a valuable archive of the university history, comprising over 30,000 photos of the university earliest events from 1988 to the early 20s, with diverse scenes including campus construction, teaching and learning activities, conference and seminar, congregation, etc. And this site was developed a decade ago. Its metadata was relied on crowdsourcing for manual tagging and user contribute comments to provide contextual information to each photo. And with the rapid advancement of AI, numerous of models have emerged in recent years that can utilize for performing tasks such as object detection, image tagging, and face recognition. Regarding this, we would like to explore the use of various computer vision models to generate more metadata for image collection, eliminating the reliance for manual processing and enhance our efficiency. This is also our main goal. Now, let's move on to our implementation part. Jack, one of the student developers who contribute a lot in this project in the past few months, He will share with us the result of his experiments on performing the object detection, image tagging, and face recognition tasks using various computer vision models. Jack has provided a pre-recorded presentation on his work, so let's go ahead and play that for you now.
Hi everyone, my name is Jack, and I'll be discussing the technique and method we used in this project. To effectively utilize machine learning, we first need a clean dataset. As the previous data maintenance has been inadequate, we begin by thoroughly cleaning the existing digital image data, for example, like removing duplicates, correcting errors, and ensuring consistency across the datasets. We then move on to data extraction, extracting relevant metadata from the image files, such as title, description, dates, and other key attributes. Following that, we focused on name normalization, standardizing the name of entities across dataset to ensure uniformity and address variation in spelling. Finally, we restructured the data relationship by designing a new database schema to better represent the connections between different data entities, including albums, photos, events, etc., allowing for more efficient storage and retrieval of information. Continuing from our previous steps, this slide details our approach to leverage AI for image processing and metadata enrichment. We begin with our existing data, ensuring it undergoes thorough cleaning and reconstructing, with the clean data in CSV file serving as the foundation. For facial recognition, we employed AI to crop and recognize faces, tagging identified individuals to enrich the metadata. Object detection and image tagging employed advanced models such as Grounding Dino and Recognize Anything, which generate tags and group similar images based on their content. Lastly, we utilize large language and vision assistant to generate descriptive tags for each image, further enhancing the contextual information available. This comprehensive process ensures that our digital image archive are well organized, richly annotated, and easily searchable. Now, let's go through the method we used and their application. The first method we used is the Recognize Anything model, also known as RAM, which is a powerful tool for image tagging that leverages tags from both academic dataset and commercial products to ensure a comprehensive tagging system. The process begins with an image encoder that extracts key features from the image, which are then processed by an image tag recognition decoder to assign relevant tags to various elements within the image. And finally, the text generation encoder decoder constructs descriptive captions, providing context and enhancing the metadata. The diagram on the right showcases how RAM integrates multiple components to deliver accurate and meaningful image tags. In our project, RAM is used for identifying objects within images. As the model processes each image to generate a detailed list of tags that describe various elements present, such as type, share, person, etc., facilitating the grouping of images based on their content and making it easier to find and categorize specific types of images. We leverage the text generated by the RAM to group similar photos, employing the T-SNE clustering method, an effective technique for visualizing high-dimensional data that helps us to cluster images based on their tag similarities. As illustrated on the diagram on the left, where each point represents an image and similar images are grouped together, with the zoomed-in view on the right highlighting a specific cluster and demonstrating how this technique allows us to effectively organize and categorize large collections of photos based on their visual and contextual similarity. The next model we used is Grounding Dino, which is a powerful tool for detecting arbitrary objects specified by human language inputs. The model takes an image and text input, then a feature enhancer using cross-attention is used to enhance features from both modalities. A modified transformer decoder then processes the enhanced features, and the final output consists of a pair of object boxes and the noun phrases, effectively linking detected objects to their descriptions, as illustrated in the diagram. By leveraging the cross-modality query and language-guided query selection, Grounding Dino effectively integrates visual and texture data to achieve precise object detection. For our project, bounding dialog is used to generate bounding boxes around each person in an image, which is essential for preparing datasets used in face recognition system, as demonstrated in the example, where the model accurately localizes and identifies people in various scenes. It enhances the accuracy of face recognition dataset. The last model we used is the large language and vision assistant, also known as LAVA. It is a model that integrates both languages, allowing it to generate detailed description from images and providing a comprehensive understanding of visual content. This functionality is particularly useful for our project in automated content generation, image captioning, and enhancing the accessibility. For the face recognition approach, it is explored by another student named Eric. Our face recognition model allows for the identification of individuals in image by comparing known faces to unknown ones. As demonstrated in the graph below, our model can identify and label people in photographs, underscoring its potential in improving the metadata for future images. While the face recognition model generally performed well on front-facing images, as shown on the left side of the slide, we encounter challenges when dealing with different face orientation, particularly side-facing images, where the accuracy significantly drops. We believe this discrepancy is due to the fact that the facial recognition algorithms typically rely on features that are more prominent in front-facing images, such as the eye, nose, and the mouth, which are less visible in side-facing images, as illustrated on the right side of this slide. To mitigate the challenges faced with different face orientation, we propose an intuitive solution that leverages clustering techniques, specifically the K-means algorithm. The underlying idea is that side profiles of the same person share similar features that can be grouped together in a meaningful way. By applying K-mean clustering, we can organize unlabeled side face data into distinct clusters, each representing different individuals. This method helps in improving the detection accuracy by recognizing patterns and similarity in side profiles, thereby reducing the need for multiple models and enhancing the robustness of the face recognition system. The clustering results were unsatisfactory. On the left side of the slide, there is a scatter plot representing the clustering result. Different colors indicate different clusters identified by the K-means algorithm. Ideally, each cluster should contain images of the same individual. However, upon examining the corresponding images on the right side, it is clear that the clusters do not accurately represent distinct individuals. The images within the same cluster are not of the same person, indicating a significant flaw in the clustering process. One possible explanation for this poor performance is the inherent complexity of the data. Facial images, especially side profiles, are high-dimensional and contain subtle variation that the K-means algorithm struggle to effectively capture. This is the end of my part. Now I'll pass the time back to Holly. Hi, everyone.
A big thank you to Jeff for sharing his work with us today. And I would also like to take this chance to thanks to Eric, our another student developer who contributed to this project. Both Jeff and Eric have dedicated tremendous effort into exploring various computer vision models and assessing their practical application in the past few months. Their efforts have highlighted the significant potential of AI to drive automation and efficiency. However, as we move forward, it is important to recognize that while AI can indeed provide remarkable automation capability, human involvement remains crucial. Human involvement is still necessary to ensure accuracy and address any potential gap in the generated information. And given our time limitation today, if you would like to dive deeper into this project, the relevant information can be found on the page displayed on this slide. In the page, you may also find a GitHub repository link, which contains all the codes and works that done by Jack and Eric for this project. And building on the work of Jack and Eric, we can take the experimental attempt and codes they have developed to do more, such as using their generation tag and descriptive metadata to improve searchability and discoverability of our image collection, and analyze the generated metadata and generated stat to uncover hidden insights, etc. Lastly, besides of the effort of our two student developers in this project to try out different computer vision models and explore the visibility of their application, we would also like to thank our colleagues Andrew, Leo, Esther, and Jennifer for their support and feedback on this project. And that's the end of our sharing today. Thank you.
Thank you, Holly and Jack, for a fascinating and enlightening presentation for Hong Kong University of Science and Technology's project, especially the RAM, lava, and face recognition models. So interesting to see metadata being used in these ways and the complexity of the projects and future development of these models. With that, we now turn to our last speaker, Mr. Filippo Mangione. Mr. Filippo Mangione is a PhD candidate in Humanism and Technologies at the University of Macerata, Italy. He is presently working on a project concerning the study, preservation, and enhancement of oral sources preserved at the Cinecittà di Bologna. He is interested in digital archival science, cinema, and history. His research focuses on the use of artificial intelligence, automatic speech recognition, and indexing to facilitate access with original oral sources. The title of Filippo's talk is Like Never Before, AI for Oral Sources, How ASR and LLMs Can Revolutionize Our View of Oral History. Mr. Mangione, the floor is yours.
Thank you. Thank you, Ray, for the presentation. Do you see well my presentation, or there is the writings on the top of the screen? Okay.
Perfect.
Thank you. So for introducing me. Before starting my presentation, I need just 1 minute to do a preamble about my PhD project to let you understand my point of view. I am studying and working on collections of interviews recorded in magnetic tape. They are stored right now at the Cineteca di Bologna, and in particular at the Renzo Renzi Library. So I think that these interviews can exemplify how many conservation entities handle a vast amount of oral documents that deserve to be preserved, even though they are not specialized in doing so. Now I need to do another short introduction about oral history, because despite being one of the first methodologies of historiography in the 5th century before Christ, thanks to Thucydides and Herodotus, oral history has never been considered equal to more traditional sources due to its scientific unreliability, caused by different factors like errors and subjectivity of memory, the influence of the historian on the source, or the immateriality of the voice. But from the 20th century, thanks to the revolution brought about by media capable of recording and reproducing speech, a different sensitivity to oral sources developed. However, not being able to delve into this topic now, I refer you to the studies of Alessandro Portelli, one of the pioneers in this field, who since the 70s has accepted limitations and errors of this historiographical methodology, examining and questioning them as peculiar elements of the investigation of the human nature and of the individual, of which the oral source is an expression. However, this approach remained confined to the environment that generated it. The reason is that those who do not deal directly or primarily with the oral sources are unlikely to come to terms with the last major criticism, inconvenience. The inconvenience in publishing, managing, and using oral sources. The main problem is figuring out what invisible content is hidden inside a magnetic tape or a series of bits. It can be very difficult to go through hours and hours of listening to understand what treasures are locked that were recording where there was not yet the current sensitivity and description standards. The first major problem can lead an archive to a standstill, which is difficult to overcome. And the time needed to listen and search for specific information remains a problem even for end users, because listening to a document is not like reading the header or index of a book. Thanks to the digital revolution, specialized archives in this field have evolved over time, prioritizing the enhancement of their collection in the terms of improving accessibility, and have started to produce time-coded transcriptions and indexes that guide users towards the use and the study of original documents, helping them not to settle for a transcribed version of the recordings. Some examples of these platforms are the Shoah Foundation, this one of the first and most important one, or Ti racconto la storia, that literally is I tell you the story, a new Italian digital library. Meanwhile, the evolution remains sectoral, and most generalist and multi-typology conversation entities are not ready to focus their resources on managing documents that are often considered less important. Moreover, the lack of well-defined standards and rules applicable in every archive and for every collection, combined with prejudice towards oral history, has made it increasingly difficult to raise awareness for proper document management. In 2021, in Italy, an important step was taken with the creation of a vademecum for oral sources. This was the result of collaboration among the most important organizations, professionals, and researchers in the field. In 2023, the work had been further updated to include a section dedicated to transcriptions. The text is a clear demonstration of the strong will to spread awareness beyond the confines of the discipline and to affirm the importance of the archive in this process, as both a starting and an end point for all research. This can lead to further discussion about the role of the archivist, who has traditionally been focused on the organization of collections and archival units rather than specific passages within documents. However, when it comes to an audiovisual materials, the difficulty in knowing the content of the original documents requires a change in perspective. Here, I would like to quote Alessandro Portelli from the Vademecum for Oral Sources. He says, "We have become respectable, we have established a method, and it is a beautiful thing. But there is no research without risk, and if we try to conduct research within the bounds defined by the method and respectability, we will end up finding only what the method allows us to find, always confirming what is already known. We will apply without innovating." So a common change of perspective can only be possible when it is the archive itself that opens its drawers and help users hear the voice they are looking for. And the title of my presentation stems from the awareness that for the first time in history, archives and conversation entities can take the first step towards this goal at a drastically reduced cost, thanks to automatic speech recognition and artificial intelligence. The exponential evolution of automatic speech recognition, shortly defined as the technology that converts spoken language into written text, began in the early 2000s, and it is a result of the increasingly widespread use across various fields of society. For example, now we have automatic speech recognition in virtual assistants, customer service, accessibility for people with disabilities, healthcare, education, and also automatic transcription and automatic subtitles like the one we have here in the Zoom application. While until recently, the most powerful automatic speech recognition system could be only used by IT professionals due to the required computer knowledge and high computing power, this is no longer the case. For some years now, more and more user-friendly automatic transcription software has been spreading online, allowing more and more people to utilize this technology. Simplified user interfaces combined with the upload of an audio file online have made the common use of this tool much easier. Considering also the reduced cost, immediate exploitation in every field of knowledge that seems to be the best option, but it's clear that a conscious use of this tool is necessary, especially when sending non-public data to external servers. So we need now to look at the pros and the cons of the automatic speech recognition. Between the pros, we have one of the key advantages of automatic transcription, the text becomes searchable, enhancing the ability to locate specific information quickly. Cost is not a trivial factor. Automatic transcription services are cheaper than manual transcription. In some cases, they are even free. In addition, they are much faster. And then there are numerous solutions available. Some systems even function locally. However, between the cons, there are significant concerns regarding privacy. The process of uploading data online for transcription can be quite opaque. Accuracy is another major drawback. Automatic transcriptions can suffer from inaccuracies and errors due to various factors, such as background noise, accents, or multilingual recordings. Furthermore, there are different levels of transcription quality, and it is not possible to choose which level of depth or fluency. Specific names and terms can be particularly challenging to recognize correctly. And it is also important to note that in interviews, the content is not the only aspect that matters. The way concepts are expressed, the tone, and the nuance of speech are equally important. Even the most accurate transcriptions can create noise around the source and contaminate the search for specific information with documents that only mention a keyword without exploring it in depth. Oral historians emphasize that transcribing their own interviews is a crucial part of their research process. This practice ensures a deeper understanding and connection with it. Lastly, bias and prejudice inherent to the data the artificial intelligence was trained on can influence the quality and fairness of the transcriptions. The choice between different and various types of automatic speech recognition systems depends on specific user needs and priorities. For those who value ease of use and faster performance without high costs, web-based and externally hosted free solutions may be suitable. But like commercial options that in the same category can offer superior quality and additional features at a higher cost, all of them need privacy considerations. In the opposite directions, open source local solutions ensure privacy and flexibility at the expense of speed and ease of use, while commercial local solutions balance privacy, precision, and user-friendliness, although they come with higher costs. Another important parameter is the quality and accuracy of each of these services. The most commonly used method for evaluating an automatic transcription is the word error rate, which measures the number of errors in a transcription by comparing it to a reference transcription, taking into account substitution, insertions, and deletions needed. The problem is that these results do not always give us an effective idea of the medium's potential. The resulting error percentages might lead us to overlay negative evaluations of a transcription compared to the good results it has produced. Errors on different characters and words haven't the same importance for the comprehensibility and usability of a transcription. A single wrong character might still allow understanding of a word, even if that word is technically incorrect. Working with archives that struggle to manage and understand their oral collection, my relationship with automatic speech recognition valuation is different. In my specific case, automatic speech recognition is not the end goal of the research, but merely a means to achieve my objectives more efficiently. For example, for the purpose of understanding and searching for information, I find it more useful to apply a different criterion, which takes into account errors made on relevant terms from a controlled vocabulary. In general, my perspective on automatic transcriptions can be summarized in these 3 points. First, transcriptions are always the result of subjective choices, and therefore the perfect transcription doesn't exist. It could be only more or less useful for research objectives. Second, the first point is not a big deal, since transcriptions, whether manual or automatic, should never replace the original oral source, but it should help the user in the search and the access to specific information. Third, I want to highlight the importance of a different approach, which aims to produce automated good enough transcription as a first step. This quote, which I fully agree with, is taken from a paper by Christian Bokov and Christopher Downey. As early as 2018, they demonstrated the effectiveness of producing a raw text. A principle valid 6 years ago is even more applicable today, thanks to the exponential improvements in transcriptions and large language model applications. These can offer various types of assistance in this sector: translation, sentiment analysis, question answering, text summarization and classification, and also word tagging. It is certainly true that in the field of artificial intelligence, it seems increasingly difficult to predict what the near future holds. Among the most ardent reformers are those trying to bring the transcription of orality to the next level through the interpretation of emotions and state of mind of the interviewers, which can be deduced from the analysis of various factors, such as the tone of the voice, the facial expressions, body language, breathing analysis, and also heart rate detection. All these parameters would entail various ethical and legal issues, and for the oral source, listening will again be put on the back burner. On the other hand, there are projects that use automatic speech recognition to benefit users and sources with an approach similar to the one I mentioned before. An interesting example is the OAVA, a Greek platform for aggregating audiovisual materials already published online, which allows in-depth keyword searches across multimedia documents, thanks to the linked automatic transcription. Despite all the weaknesses of automatic speech recognition that emerged during this presentation, there is a necessity that in the context of my research pushes me to overcome them all. The necessity for archives to know their documents and how to enhance them. Finally, giving voice to all those unheard testimonies that have remained locked in our drawers. Thank you for your attention.
First of all, thank you, Filippo, for a fascinating and intriguing and also historical talk, a nuanced contextualization of both oral history, automatic speech recognition, and these complex relationships with transcription, automation, oral history, and AI. Much to think about there for all of us here. Now, to transition to our question and answer period, and before our question and answer period, I really would like to thank all of our speakers for a great round of amazing talks on the future and present best practices for practices of digital preservation and oral histories through AI. The range and breadth and complexity globally was really amazing to see. And I look forward to seeing all of these great presentations published as papers later this year so we can dive into the details. I'd now like to open it up to audience questions. Perhaps we could begin with the chat. I would ask members of the audience to ask their questions in chat and mention which specific speakers to whom their question is directed. I know we are constrained for time right now in our last 10 or 15 minutes, but I'd like to ask my fellow committee member, Alenka Kavcic, to also unmute and read 1, 2, or 3 questions from our group, if there are any coming in, specifying the asker's name and speaker to whom the question should be directed before we begin concluding remarks. Alenka.
Thank you, Ray. There are 2 questions in the chat. One is to Herbert, Menezes, Dorea, Filho. We have many digital libraries in the world that we need to search one by one. Is metadata the way to integrate all these libraries? How machine learning software AI field help us in this integration?
Hi. The integration of digital libraries can be significantly improved through metadata structure. excludes identified titles, authors, publication, dates, strategic keywords, and themes. Recognizes the methodology of people, places, and events. In addition, the standardization of metadata and the classification and categorization of documents are crucial to ensure consistency and easy navigation through the collection. I am available to exchange more information.
Thank you. Now the second question was to Filippo Mengoni. How much data you need to train the model for ASR?
For me, at least you can use 10 hours of recording to improve the performances of automatic speech recognition. I don't have already used them for improving the performance of one system in particular. I try to use Whisper AI, that is already a very good software, an open source software. But for answering to the questions, 10 hours of transcriptions, recording, and data that are already tagged with specific information and specific terms can be enough.
Thank you.
Depends from the different situation. If you have a lot of data to train, or from a starting point, 10 hours can be enough.
Okay, thank you. Well, there are three participants that raised the hand. One is Gildenir Carolino Santos. I hope that they have the possibility to speak. Gildenir Carolino Santos, are you still with us?
I gave the right to speak.
Okay. Nothing.
Maybe
Well, there's another one, Marin Bados, Francisco Javier, and Andrew Wong. So if you would like to raise any question, please let us know. Nothing happens. Was this a mistake? Or, well, I have one question for William. I know that the artificial intelligence is everywhere, but concerning digital preservation, in your organization, in the Digital Preservation Coalition, do you deal with the impact of artificial intelligence in digital preservation, or this is something new that you raised today?
Okay, so that's a good question, Alenka. Let me try and put 2 or 3 pieces together for you. So, you know, we are a coalition of members, and so insofar as we deal with artificial intelligence, it's because our members deal with artificial intelligence. So it comes to us through our members. And what we are able to do, therefore, is have a bit of a high-level view as to what different parts of the sector are doing, what different parts of the digital preservation community are doing. So being able to influence and to bring together, this is for me important. We've got a great set of case studies here today. We need to make sure that the case studies are matched to the people who can take advantage of those case studies. So that, for example, Filippo, your work around oral history, right? This is sensationally important, but for quite a niche group of people. And it's difficult to reach those groups of people effectively. So bringing people together turns out to be the key. Actually, it's not what you know, it's who you know, if you like, in our kind of work. So thinking then about artificial intelligence within the digital preservation community at large, there are many open targets that we could think about for artificial intelligence. I see in the chat a mention around Droid, for example. Droid is a file format recognition tool. It's a very important tool. It's supported by the National Archives in London, who do it really for their own purposes, but share it with everyone. If it depends a huge amount on a publicly accessible database, actually. And the trick to Droid isn't so much the tool itself as to populate the database. Now, this would be a wonderful project to see if we could train AI tools on that sort of project. Like, where are all these unusual file formats? And just a little bit of statistical analysis suggests that Droid is good, but it maybe only has, what is it, 4 or 5% of the total? I need to cross-check those figures, but certainly only a proportion of the total of file formats that you'll meet in the wild. There's also a question, if I may, in the chat. I see an observation from one of our colleagues around persuading organizations to get involved in digital preservation, and maybe I could take a moment on that as well, Alenka, while I'm speaking. So firstly, the observation is rightly made that all organizations, whether they think of themselves as libraries or archives or not, almost every public sector and almost every kind of commercial agency has some digital preservation challenge right in front of it right now. It sometimes expresses digital preservation in business. You might actually often refer to it as technical debt. So organizations are embedding large amounts of debt that they kind of need to pay back in technology terms, and they need a digital preservation solution to deal with that. And how do you persuade companies to do that? That's the trickier part, and there's not a simple solution. But I can help you with the set piece of high-level advocacy. You know, the DPC exists partly for raising awareness. So things like the bit list, there's a global list of digitally endangered species that we manage. So you find your stuff on the bit list, you know you've got a problem because the community is saying, this is hard, this is difficult stuff to look after, and there are steps that you need to take. Similarly, we celebrate good practice, you know, celebrating awards. This is an awards year. We're giving out awards this year for good practice in digital preservation. So there are certain set piece types of support that we can give. But actually, the answer to every digital preservation question begins with it depends. So how do you persuade a manager to invest in digital preservation? Well, it depends. It might be easy to do, it might be hard to do, it might be part of the organization's mission. They might think that they've invested in it and bought it and think it's a product. Digital preservation is not an app. So you can't just buy it and install it and think you've done a job. Actually, you need to make the commitment, and the commitment is an ongoing commitment. What would help us enormously is if we could put data on the balance sheet of companies, because then the Risk and Audit Committee in any organization would suddenly be alert to the idea that this is an asset that they should be looking after rather than a liability, which is drawing money out of the core funds. But in any case, I'm up for that conversation. And I'm up for that conversation about trying to persuade people, trying to persuade senior managers about the need to invest in digital preservation. One final observation, there's a little tool called there's 2 RAMs now. There's a thing that the DPC has provided called the Rapid Assessment Model, which allows you to compare yourself to where you are now and where you'd like to be in the future, and sometimes to compare yourself with competitors. And comparing yourself with competitors is a wonderfully influential tool when you want to persuade a manager of anything, really, because the worst thing you could do is to be less good than the people that they expect to be better than. But it's maybe moving into slightly more cynical tactics now. I should stop before I say anything incriminating.
Thank you, William. And I think actually that's a great set of comments to conclude on right now, because we are almost right at time. I just want to make a couple final comments in terms of beginning to conclude now. There will be a recording of this event sent out to everyone, and we're also going to make the speaker slides again available to everyone. Later in the year, we're again hoping that all of the speakers, including our keynote, will consider publishing in the special issue of Trends and Issues in Library Technology, because this would be a fantastic group of presentations to focus through a detailed reading in some of the complexity in terms of the speakers' presentations. There's so many great projects and talks that we witnessed today. And I'd like to wish everybody a great rest of their morning, afternoon, and evening, and thank again our keynotes and panel speakers, and wishing everyone a great rest of your day, and thank you for attending. Have a good day, everyone.